stream. Hi, stream. I actually unmuted the mic so you can hear me now. So, hi, people on the stream. We're going to kind of follow similar sort of format to how we did last week. We got some really great feedback about how we handled the news. We're going to do like a slightly different variation of it. First things first, though, let's talk about some club business really quickly. First off, I believe we're going to be start doing some orders for hoodies again this year. Clinton, if you want to, is that what you were here to discuss, I assume?
That and Monaghan's.
Okay, also, how many people are wanting to come to Monaghan's tonight? Hands up, please. And 2 for me.
So I'll say 15. Because there's always going to be more people.
Yeah. Cool. Clinton, if you want to tell everyone about the sweaters, for those of you who don't have ISS hoodies. Yeah. No, it's too hot for hoodies right now, man.
So, hoodies is done by the school, or third party by the school shop. These sweaters cost $40.
Sweaties.
$40, you can get this sweater. $10 if you want to customize your name or username. Get those Hacker Elite names on there. You get the top of the hoodie, the sidearms, each $10 each, so you can spend up to $70 plus tax on your sweater if you really wanted to. We'll probably put the due date by October 20th. We just need minimum 12, but looks like we don't have to worry since we have pretty much like a whole new generation of security people. Yeah.
So we'll post more information as soon as we have like a sign-up sheet or anything like that. I'll put it up on the ISSessions.ca website, and we'll also post links in Mattermost, et cetera, et cetera, et cetera. Yeah, and we'll blast out stuff through the mailing list. If you're not on the mailing list, by the way, or following us on Twitter, I suggest you do one of those 2 things at the very least, just so you have an idea of when we're having events and things like that. Last but not least, so we've been getting apparently some interest about our potentially upcoming CTF. So thanks to my procrastination, so we're probably looking at like a January, February kind of time frame for this.
Just pick a date. God, pick a date.
I'm not going to pick a date right now without actually looking at my schedule.
January 21st.
No! Yes. Go away.
January 21st.
No. So anyways, I will be picking a date soon, and then essentially, I'm going to pick a date soon, and then essentially what's going to happen is I will need I'm going to need a bunch of volunteers. The first batch of volunteers that I am really going to need is going to be, I'm going to need some kind of more experienced people in terms of technical aspects. So I'm talking like probably 3rd, 4th year kind of people. Some of the 4th years when they come back from co-op, I'm kind of hoping I can swing some of them in. And because I'm just going to need people to kind of come and help build challenges for the CTF. And that will be something where you can essentially build a challenge independently of any other tasks with the CTF, and then we can just integrate your challenges into the CTF however we need to do that, right? So that means that you're not dependent on anything I'm working on or anything that any other people are working on for challenges. And you can also, of course, if you and a couple friends want to build some challenges for the CTF, great. The only stipulation is that if you are building challenges for the CTF, you cannot play in the CTF. But at some point, once I pick a date, then we'll actually start pulling together any volunteers. And at the same time as well, we're going to probably start kind of having regular, somewhat regular online meetings just to make sure things are running along. So it should be lots of fun. And for those of you who don't really know what the whole concept of a CTF is in the context of what we do, it's basically like solving sort of InfoSec and hacking puzzles and that kind of stuff. You solve a puzzle, you get points. Whoever gets the most points wins. Yeah.
If you've ever played Capture the Flag in an FPS game, it's absolutely nothing like that. Nothing.
Not at all. Not even a little bit. No.
There's no clear instructions really.
No, it's, I mean, so essentially what we're planning on doing is having sort of different categories of challenges where you might have a web-based challenge or, like a forensics-based challenge. So you at least have sort of an idea and you'll have the basic instructions. Yeah,
So essentially,
use the mic. So everyone on the stream can hear you.
so essentially, is it just like a recall for everyone themselves? Or
It'll be team-based. So what we've done in the past, I mean, we've only run the CTF twice, but what we did last time.
There's been like 4.
Really?
Yeah.
Sheridan CTFs?
Yeah.
No, we've run 2.
No. I did one, you did one, Brian did one, and then we had like another
When
random
you
one.
did one?
The very first one was me just
Really?
running it, yeah.
Where was I?
You weren't here.
Okay,
It
anyways.
was turn 6 here.
Oh, was it?
Yeah.
Okay, anyways. Yeah, basically what we're going to likely try to do is when we get people to sign up, we'll have them state like what year they're in, and we're going to try and make the teams a good mix of people from different years so that it's more a learning experience than like sort of fierce competition. Because when we do it competition, the fourth year people will obviously have a bit of an edge for the most part. So we want to make sure that we don't have these like stat teams or anything, and we want it to be a learning experience for everyone. So yeah, anyways, so what we're going to do a little bit different with the news this week is we're going to do like, any fans of Last Week Tonight in here? John Oliver's show? Okay, so we're going to do kind of like a quick rundown of some headlines, just like a really quick, hit a few of the big headlines, and then we're going to dive into like one sort of big story
of the 2 weeks.
Yeah, which is, I think you probably all know which one we're going to talk about because it's the kind of the hot ticket right now. So let's get into some headlines. So first things first, a little update on the never-ending saga that is Yahoo. So apparently it wasn't like 400 million accounts. It was all 3 billion of them. Okay, now I have some questions.
Of course.
The first question is, there's 3 billion Yahoo accounts?
Yeah. The whole
Really?
the whole of humanity. Like everyone has an
Everyone
account
who's
on-
ever touched a computer has a Yahoo account,
yeah, of course.
apparently. And that can't possibly mean that there's people who used Yahoo and just automatically signed up for hundreds or thousands of accounts to send spam, because that's totally not a thing,
No,
right?
not at all. Not at all.
So these are all definitely 3 billion unique people that have had their Yahoo accounts compromised.
This was like the 3rd revision of that number. Too.
Yeah.
If you remember
Yeah.
the story from last year, it was like 400 million, 600 million. Yeah, we think about 1 billion. And now, like a year later, it's actually like every account in the system.
Mike?
Is it just email accounts or
Your Yahoo account. Your Yahoo account is
It's like a
automatically has a Yahoo email address associated with it.
Okay.
Yeah. GeoCities? Did Yahoo buy GeoCities way back in the day?
All right.
I had a GeoCities page. I'm not gonna lie. I did have one.
Did it have lots of animated GIFs on it?
I don't even remember.
Like
this
a, like a
point.
spinning skull and crap. Yeah.
It was pretty much like Homer's homepage.
Yeah. All right.
Just like dancing Jesus and everything. Okay, so anyways, there's some kind of interesting things, like, the timing in which they released this information. I had kind of mentioned on Mattermost that it was sort of interesting. Like, I kind of picture in my mind that Yahoo PR was kind of like, big disastrous hurricane? No, not quite yet. Well, another big disastrous hurricane? No, not quite yet. 2 hurricanes and the worst mass shooting in U.S. history? Yeah, that sounds about right. Let's release this news. Because everyone's paying attention to other
kind
stuff.
of like sneak it in there.
Right? Let's just like sneak it in there. It's been a really crazy past few weeks for news. So, let's just kind of like slide that in there. No, and honestly, people kind of talked about this, but it was mostly just people casually mentioned it, and then they're like, okay, moving on to like all this other crazy stuff that's going on.
Like we should do right now.
Yeah, like we're going to do right at this moment. So for all my Apple fanboyism that I tend to show, this was kind of a really big, bad screw up on Apple's part. So basically what happened was when you created new Apple file system, basically encrypted volumes, and you provided a password hint, what would wind up happening is it would actually, instead of showing you a password hint when you tried to unlock the volume, it would just show you the password.
It's a really good hint, though.
It's the best hint
probably
possible.
the best.
It is the best hint you can possibly give, but maybe it's a little too good. because I think it goes beyond hint at that point.
Yeah, that's true.
So, however, the beautiful thing is that from the time that this was actually publicly disclosed to the time that it was fixed was about 2 days,
Something like that.
right? There was no, waiting for like a monthly patch or, waiting for a major OS update. Apple pushed that out real fast. They fixed it very quickly, so good on them. Because even Apple makes simple programming mistakes once in a while. It happens, right? You basically, you pulled from the wrong field in your dialogue to...
Instead of dot hint, you
Instead of
printed
dot
dot
hint.
password.
Yeah,
No,
exactly.
I get it. Okay,
Exactly.
We all been there.
So yeah, that was a rare, rare chink in the armor for Apple.
Yeah. So a quick follow-up to last sessions is like deep dive topic where we pretty much talked about what we thought was every aspect of the Equifax breach.
And then the
there was a
CEO.
little bit, well, there was a little bit more. So first they tacked on another 2.5 million people who were potentially affected by this thing. And then in addition to that, the CEO had his day in front of Congress and the U.S., judicial
The U.S.
system.
House Subcommittee
Thank
on
you.
Consumer Protection,
Subcommittee on
as I read from the screen.
Thank you so much. And basically, this is where they just grilled him and asked him tons and tons and tons of questions. The unfortunate part is sort of the big takeaway from that was he kind of all pinned it all on like one sysadmin and said, "Oh, it was this guy's fault,"
Without naming the actual guy.
which was kind of inappropriate. I mean, if you're the executive, you're supposed to take responsibility. You don't blame like the one lowly tech who probably wanted to patch this thing, but because of all kinds of overhead couldn't or didn't for whatever reason. I mean, I don't know this person. Maybe they did suck at the job.
I
have no
mean,
idea.
maybe, but
But that's an inappropriate thing to say.
But
about
regardless,
an
you're supposed to
employee in a
have
company.
you're supposed to have controls in place to potentially mitigate if someone messes up on a patch, right? You
Yeah.
can't just blame. Well, we were supposed to apply this patch and we didn't. There's a lot of other things have to go horribly wrong
To expose all that
to
data.
expose 100.
Yeah.
What is it, like 145 million now?
Yeah.
145 million social security numbers.
Like, the
It's,
best comment
brutal.
on that, or the best what do you call it? The thing where you use another story to compare the thing. I can't remember the word right now. Whatever.
I don't know.
The best comparison that I heard online was it's like a company
Analogy?
blaming. Thank you, analogy. It's like a
Okay.
company blaming the fact that they didn't submit their tax return because someone didn't put a stamp on the envelope.
Yeah.
And like it was the stamp guy's fault that someone didn't get their tax return. Like that's the equivalent of that kind of blame. There should be all kinds of other things that have to go wrong for that.
And rightfully, the community sort of basically just shit all over this guy and said, definitely no, this is not the way you handle this kind of stuff.
Yep.
Vulnerability-wise, so DNS mask, you may or may have no idea what DNS mask is, but I will guarantee you have at least one thing in your home that runs DNS mask, and it's probably your router. So DNS mask is basically, it is a DNS proxy or a forwarding DNS server. Right? So all it does, it basically says, I'm going to act like a DNS server, and when I want to find out, what IP address is Google.com at, I ask DNS mask, and DNS mask says, okay, I'll ask my DNS servers, and then it'll pass through the answer. So a lot of home routers, like a huge number of home routers run this. An insane number of like embedded devices, even IoT devices, all run DNS mask. It is an open source project that is basically done by one guy. And Google basically found a whole solid whack of vulnerabilities in it. Some of them are more
7.
Seven. Yeah.
Seven.
Some of them are substantially more severe. Some of them actually don't even affect DNS because DNS mask can handle things like DHCP as well. And some of them only affect very specific versions that likely your router doesn't have because your router's probably 50 versions behind anyways. So so it's kind of interesting because we have these open source projects that are so pervasive in the technology we're using all the time. And we have no idea all the different pieces that are going into something like our home router. This was big. Maybe not as big as researchers would always like to make it out to be, but it's still relatively serious.
It's fairly widespread. I mean, you make the
It's
argument
widespread, but the difficulty of attacking this is quite high. Like you have to have sort of an internal network position typically, or you have to get someone to query your malicious domain.
Yeah.
Right? And that's generally how most of those kind of DNS vulnerabilities work. Another big one in the U.S. So the White House Chief of Staff, John Kelly, apparently his phone has been hacked for like months and months, his personal phone. And so the big thing here is, so apparently he has been primarily using his secured, like work phone. However, if you're still carrying around your personal phone, especially if it's an Android and it's been owned and it's been silently rooted, that thing's a listing device, straight up.
Yep.
So that is like, very, very, very not good.
And from just an IT perspective, the commentary I heard on this was that for a long time, he was suspicious of the phone. Him and a bunch of friends were looking at it. They're like, why do all the apps keep crashing? Why is everything going wrong? I think if you're like a high-up member of a governmental body...
Assume someone's screwing with you at that
something's wrong
point.
with your phone. Yeah, so what they ended up doing was eventually giving it over to their IT group, and apparently it even then took the IT group a long time to figure out, we think this thing's compromised. Like... By then, there's been an awful lot of damage done. I don't know what a good internal process there should be, but obviously that was not necessarily a good thing.
So there's lots of discussion to be had on sort of how he may have gotten breached. How they handled it. Maybe not giving people the tools in that kind of high security situation, not giving people the tools and knowledge to be able to sort of say, hey, if anything even slightly weird happens on your phone, hand it over to us for the love of God, like right away. Yeah. Mike?
Okay, run.
Run.
To be fair, he did run.
Yeah, he did actually run, so that's good. Yeah.
Yeah, it kind of baffles me, just because of like the position he holds, that, I get they have a secure work phone, but like for somebody of that, importance in like running a country and helping running a country, their personal lives should be like of equal importance.
But you're assuming competency here.
Yeah, no, exactly. But no, that's the part like I think that needs to be changed and adopted in different business environments, that security isn't just at the workplace. Yeah. Right? It goes all the way back home.
Oh yeah, and obviously we're going to talk about that in our main story.
Yeah, the adoption of BYOD it's a nightmare, right? So yeah, it's just more of a comment.
Yeah.
Cool. Thanks, Mike. So yeah, that's not a good look. And one that we have to talk about, but we're not going to talk about too much, simply because there's too many people with including current or former Deloitte employees, which cannot really talk too much about this. But I have no problems talking about the existence of this whole thing. So basically, what happened was there was a big thing that Deloitte's email system had been breached. And immediately what started happening was a bunch of security researchers went out and started scanning and hunting through Shodan for anything that said Deloitte on it. Now, to be fair, I'm going to come out and say that Deloitte is, like all the big four, is not one just giant conglomerate. They're actually completely
many multinational.
They're many like sort of individually managed firms. They have their own IT, they have their own security, and the firms are of varying sizes. So, for example, I was seeing some people pulling up some stuff from like Deloitte South Africa. Well, Deloitte South Africa is probably not going to have anywhere near the resources of, let's say, Deloitte US, obviously. Now, that being said, still not an excuse for exposing, like your domain controller to the internet, which is probably not a good thing. But that the other kind of side of this is, as well as people say, oh well, they can't be trusted to sell these kind of services, consulting services, if they can't even secure their own stuff. But the reality is that the consultants, which obviously was one, the consultants are spending their time working for clients, and very rarely are they ever even asked to look at the internal security. They have internal security teams that do that kind of stuff, and they are completely separate from the people who are then going out and helping to secure clients.
The consultants are the product that company sells, right? They're not the internal management and infrastructure team.
Yeah. And I mean, every once in a while they may be asked to, help out. Hey, can you guys scan this or do this thing on our internal network? But for the most part, they're not tasked with defending, Deloitte's network. So
if you do ever have the joy of sort of being a consultant at any kind of firm doing that kind of work, you'll realize that actually a lot of time you try to keep your distance from the internal administrative team for that reason. It's almost like a boundary of professional courtesy, right? You don't tell them how to do their job, they don't tell you how to do your job, right? It's the same reason that we've, like this program, many of the people in the room are in, or were in. We study InfoSec and IT security, but we tend to keep a bit of a gap and a distance between us and the school's information security team and security department, because again, we don't tell them how to run the school's network, they don't tell us what to teach in class and what work that we should be doing as a program. And there's kind of that barrier there, and I think it's better for everyone when we sort of leave that in place.
But yeah, either way, there's a lot of stuff that's not a good look for Deloitte in general, and unfortunately, the brand does get completely clutched together, regardless of the fact that they're independent entities. And there was some bad stuff. People started hunting through GitHub and were finding like remote access passwords and all kinds of fun stuff. But however, I feel like you could probably do the same thing to any of the big four, and you would probably find similar stuff.
You could. And
Very
you
likely.
think they lost a single client over that?
No, probably not. They probably the partners probably had to feel a few angry phone calls, but that's about it. They probably they just took them out to dinner and all was good. All right. Okay, so that's kind of our roundup of our big major stories, except for the big one, which, as you can all maybe guess, is going to be about Kaspersky.
Well, John figures out how to use a Mac.
No, I know how to use a Mac, sort of. So, all right.
So first off, if
you are, go ahead, go for it. No, go for it. I talk enough.
Fair enough. So for quite a while, the antivirus company Kaspersky has been getting a lot of comments and a lot of slack from people in the information security world, or just other places, because obviously they are headquartered in Russia, and right now things are a little bit tense between Russia and the United States. And they often kind of get called out. People are saying, well, how do we know you guys aren't colluding with them? How do we know, you're sort of not in their pocket and stuff like that? And people have been a little bit wary. There was a couple of months ago, there was an advisory that went out that sort of suggested government agencies in the US start to migrate away from the use of Kaspersky products inside their environment. Then, a couple of days ago, this story comes out that's essentially without... we obviously don't have loads of facts on this,
No.
And by say we, the people writing stories about that. But now they're kind of trying to tie Kaspersky to the leak or the sort of breached set of tools from the NSA that eventually then led to the auction of the tools by shadow brokers that then led to the tools going open that resulted in somebody writing the WannaCry worm that it sort of chained into a whole nasty mess of stuff in the world. But the theory now, or the accusation now, is that actually the initial point of compromise for this NSA toolkit actually happened because of Kaspersky and some role they may have played in it. Allegedly, at least the way one of the stories goes, is that maybe a contractor...
Which is stretching, by the way.
This is a bit of a stretch, yeah. Is that maybe a contractor or someone working with or for the NSA had a copy of the NSA's tools on their machine, whether it was like a laptop or a desktop or whatever. And they were also running the Kaspersky antivirus product. So the idea is that the antivirus product, it scans the files on your system, it tries to profile them, it compares them against known signatures for things that are known good and known bad. And sometimes you come across a file when you're doing scanning like this and you're like, okay, we don't have signatures for this thing, so it's not known good, it's not known bad. And this application, maybe it's either demonstrating some behaviors, it matches some heuristics or some rules that seem a little fishy. So what your antivirus suite will do, and many antivirus suites will do this.
Including Microsoft's.
Including Microsoft's, yeah, and Symantec and all the others, will take the file and it'll push it up to the antivirus company's sort of cloud or infrastructure for further analysis. So the idea, or the current, the theory or the accusation is that all of this sort of collection of NSA tools got pushed up into Kaspersky's environment somehow. So from there, it either goes like this. Either Kaspersky found it and they're working with Russia and turned it over to Russia, or someone inside the Russian government had a like a tap on Kaspersky's network or their systems, and the company didn't know about it, and they got the stuff that way. The other one is that they did know about the tap. They didn't really help them, but the company tapped their stuff and read it anyways.
There's also secret option number 4.
There's
I mean,
the equivalent of like
we'll get it, yeah.
There's the equivalent of like a FISA warrant where they say, hey, we want this, and you can't tell anybody we asked for this. There's also stuff like back in 2015, apparently Kaspersky reported that they had a security breach. Maybe tools were accessed then, haven't been uploaded from this person's laptop. So there's like a whole bunch of potential root causes for this, and it has obviously put this company under intense scrutiny and a lot of fire.
Now, so I think one of the, I mean, just if you look at the original, I think it was Wall Street Journal story that broke this whole thing, you know, you have to be very, very critical and very, very careful about the words they choose to use when describing what happened or what they think happened, right? So one thing that I have to really draw close attention to is the fact that they said Kaspersky was exploited. Now, in you know, very specific technical context, that has a very specific meaning. However, you can't necessarily trust you know, the Wall Street Journal to necessarily get the nuance of, you know, using a word like that correctly, right? So that word exploited could mean, you know, a multitude of things. So as Nick was saying, there's, you know, several different ways that this could have gone down. But as we know from wonderful Tavis Ormandy's work, is that antivirus suites in themselves can frequently increase the attack surface of the system they're installed on because they are effectively, you know, their behavior for the most part is at sometimes indistinguishable from that of a rootkit.
Yes.
Right? Because it has access to all these low-level functions on your system, and you know, it can basically do just about anything on your system, and you've willfully allowed it to do that. So there is also that aspect of it where, you know, Kaspersky, it may have been their software involved, but it doesn't necessarily mean that they had anything to do with it other than the fact that, hey, software has vulnerabilities and it got exploited.
Yeah. So the questions now are things like, to what extent was this company involved in the breach of these tools? What was their awareness of the situation? What was their involvement in the situation? Yeah.
What's also interesting, I think that I heard that what happened was in between this news story and the previous news story about the U.S. saying basically don't use Kaspersky. The founder Eugene Kaspersky, he offered the source code to the United States government to do a full-on audit. He said you can take all of the code and you can look through it. He didn't get a reply.
Yeah.
Yeah.
And according to one of the theories, though, is that wouldn't have mattered, right? If it would have pushed the code up to their servers and someone just comes by and says, hey, give me that data, you're not going to see that in the source.
So that's the thing is this, so, you know, we start to talk about this whole, you know, cloud antivirus, right, where, you know, and again, by default, and the recommended setting that you will be inevitably pushed into enabling unless you ignore the warning on, for example, you know, the antivirus that comes with Windows 10, by default, will upload interesting samples to the cloud, right? So, you know, they can give all their code over, and let's say, hey, there's nothing intentionally malicious in there at all, and let's say they don't even find any glaring vulnerabilities. You know, I bet Tavis with the source code could work some magic, but maybe they don't find any obvious vulnerabilities. But that's still that functionality in and of itself is still, for this type of situation, inherently bad for keeping those kind of you know, secrets. But I think what's starting to really dominate the discussion now, in addition to the Russia stuff, is the behavior of the contractor who took this stuff and put it on his personal laptop, which is a huge no-no.
Yep.
So now you start getting into like sort of policy things and the fact that contractors have been a huge problem since Snowden, obviously.
Since, like,
forever. Since forever.
And contractors are like a neat security problem. So like this tangents off into a whole bunch
a neat problem.
A neat, yeah. There's a whole like a cool realm of stuff that pops up, right? So contractors in general, like these foreign entities inside of your network. So how do you control and how do you manage that that kind of a presence, right? Do you have to like lock down their access, restrict their access? Do you provide them with their own hardware? Do you let them bring their own hardware? What about data access control? How do you, manage what they see, what they access, what they remove from the site, what they may even accidentally remove from the site, right? Because again, they might be on site using their own laptop to help you with some work. As a result of that, maybe a file lands on their laptop, maybe intentionally or unintentionally, and then their company's antivirus then pushes it up to the cloud. They might have been completely ignorant of the fact that that happened, but it's something, if you're in sort of the situation where you're managing a network, you kind of have to think about this when you have these outside entities in your network. How do you lock them down? How do you restrict them? How do you control them? Then the other problem is that you've likely then given them some set of permissions to do whatever it is they need to do on your network. When they leave, how do you audit those permissions? How do you remember to revoke all those creds and examine what they did touch and what they didn't? Like obviously, if they're bringing their own hardware, you can't force your own like group policy on them for Windows security stuff. So there's a lot of layers to having a contractor work inside your environment.
Yeah. So there's a lot of different angles on what role Kaspersky specifically played in this. So apart from the fact that Kaspersky AV was involved in some way, there's really no concrete information on anything. Most of the stuff is primarily what I would say raw speculation at this point. Yeah. I think a best case for Kaspersky is that, hey, their antivirus software works really well and identified a potential 0-day and was like, hey, let's upload this so we can analyze it. So obviously, if you're working at an AV vendor and you see something, you're like, wow, okay, this is exploiting something that we were not aware of. What are you going to do? You're going to probably pull it apart and start mucking around with it, right? Now, Kaspersky being Russian doesn't mean they're necessarily, sort of in bed with the Russian government, but I imagine to do business in Russia, you probably have to have a fairly high level of cooperation. I'll leave it to the Russian to answer that. I imagine you have to have some level of cooperation with the Russian government that is probably beyond what is required of a similar American firm or Canadian firm. Although we don't know with the American firms because they could be doing the same stuff, right?
Other challenges and things that this brings up, like a lot of people are for the first time discovering that their antivirus product ships data and software out of their organization up into the cloud. So maybe it'll start
it brings the whole people uploading stuff to VirusTotal, right?
Yeah, so it'll start some interesting discussion around now you got to do maybe a better audit of the software that's running on all your systems internally. Do you really know what it's doing? What kind of data it's exposing, what it's uploading? Like John said, with VirusTotal, a lot of people, if they suspect a file that they've got, they'll upload it to VirusTotal. What they don't know is that, then a lot of people can go and also access that file and look at the contents of it. I think it was DA667 on Twitter was tweeting out links to all kinds of crazy internal private company PDFs that he just found people had uploaded to VirusTotal. So that's awesome.
And I would say probably a huge number of internal teams, that deal with potential malware and stuff like that, have subscriptions to VirusTotal and can upload and can therefore also look for other samples. Because we use VirusTotal at work ourselves, our malware analysis team. They really rely on VirusTotal quite heavily.
Other stuff, the whole network perimeter thing. So again, if you're thinking about this contractor, your network no longer ends, at the boundaries of your office place and with your own employees. Now your network ends at a contractor's home, right? Now this guy took data out of your network on his machine, brought it to his place, but it's still your data. So what are you doing to make sure that, to the best that you can?
And how screwed is this contractor, by the way?
Oh, probably pretty screwed.
He's gonna get charged almost for sure.
It was a first notice.
No, he's definitely dead by now.
or he already lives in Russia. Let's Eugene Kaspersky. He's been pretty candid through all this sort of stuff. I don't know if you guys can see this at all. We're a little laggy. There we go. So yeah, Kaspersky themselves, no one's giving them any sort of actual information to sort of help them, properly refute the claims. They say they don't have inappropriate ties to any government, including Russia. Well, if you're a Russian company and you feel that there's something that could potentially endanger citizens of your country, would that not be an appropriate relationship with the government entity? I don't know, right? Like I said, I mean, private organizations being fully independent and autonomous is something we, somewhat take for granted in Canada. Because I know, in my work, we don't have government organizations coming and beating our door down to say, hey, can you send us that POC that you just came up with for that new vulnerability? And
if they do,
that I know of, and if they do, they're going to.
You wouldn't be able to
it's not my problem at that point, anyways. So, but yeah, so Eugene Kaspersky released this statement, basically saying we don't apologize for being aggressive in how we detect malware, and that we want to be able to analyze potentially new pieces of malware, new exploits, that kind of stuff, which is a totally reasonable position to take, honestly. We've said several times, every vendor basically does this in some way or another. There's a lot of different weird motives that could be in play here, as to why they've decided to really heavily, play the Kaspersky angle here. Wired has this really a pretty lengthy piece on sort of that the NSA officially has a problem with rogue contractors, which I don't know if this is now the point where we've officially decided that, I suppose, but Reality Winner wasn't terribly sophisticated in how she tried to exfiltrate stuff, and she got caught, but it still stands to reason that it seems like they do have a bit of an issue with contractors, whether it's intentionally and willfully, which obviously in two cases has been the problem, and in this case was that he took stuff that shouldn't have been taken way outside of their control. And
the really
InfoSec is hard.
Yeah, it is. Shocking. The unfortunate part about this story, though, is that we might really never get all the facts, because when it starts to involve governments and stuff like that.
Yeah, and so now because we're already in the midst of this big sort of geopolitical battle with Russia. We're in the midst of Cold War 2.0, and at this point, effectively, and
You should.
I just did, by the way. That is trademark. Yeah, Cold War 2.0. The colder war. Cold War II, Electric Boogaloo. Even if Kaspersky isn't necessarily complicit in this, it probably won't matter at all if they're not. No. At all. Even if, let's say, best case, something comes out that completely exonerates them of being directly responsible, they're still not going to get enterprise sales in North America at all, for the most part. No one would consciously make that decision at this point and say, hey, I think we should totally go with that Russian antivirus product that may or may not have been involved in stealing secrets from the government.
You think that, do you?
No, so Best Buy. So as a former Future Shop, aka Best Buy computer technician, we did use Kaspersky for many years, and basically Best Buy up until recently for their Geek Squad services used Kaspersky as their primary sort of add-on antivirus, right? And
I think he was talking about pulling it from the shelves.
Yeah, but I don't think it's been pulled from the shelves directly. It's just that they've changed to something different for what they use for their actual installation services. They're no longer specifically endorsing it, but they haven't specifically pulled it off the shelves. But again, if you're a consumer and you pay any attention to the news, which I know a lot of people don't pay attention to the actual news, they prefer to get it from Facebook. But if anyone, and
just a little dig at social
just a
media.
little dig at people who get their news from Facebook, just for the sake of it. But the other part of it is that if this gets into the mainstream news at all, that's going to affect their sales, their consumer sales. Now, that being said,
See, this is where I'm gonna call you on that. I don't believe you. Remember when it came out? I can't remember how many years ago now it was that we found out that maybe a lot of networking equipment that was coming from other countries had maybe been backdoored at the CPU level.
other countries, meaning China.
I don't like to be too specific. Be general.
Well, it was specifically about one company, Huawei or whoever the heck you say.
Yeah. That was one set of devices, but there was other stuff
yes,
going
yes,
back
yes.
about like others, like Cisco devices and
Yeah,
stuff like that.
they were being
And-
modified in transit.
Yeah, they were being patched in transit and stuff. I didn't see really any dip in people using Cisco hardware. Right?
Well, but when it comes to Cisco hardware, you don't really have much choice a lot of times in
What do you
terms of
got
what you
What
use,
you got it against? Was it-
right? They've got the market cornered, right? Whereas, let's say you're someone who's now, you got your computer set up at Best Buy and it's got Kaspersky on it, and you're like, oh, the Russians are hacking my computer.
I'm just saying that
you know.
I don't think the average person, no offense, gives a shit.
Well, and also, and I guess the people who are getting their news from Facebook think the whole Russia thing's complete bullshit anyways. So, and they love Russia, so, right?
Yes.
Yes.
So,
Da.
touch base on that.
We'll get you that.
John
Yeah,
yeah. InfoSec is hard, right? So I was actually talking to
No.
someone today where it's like, you see, beyond college, beyond the program, everyone's budget is invested in that network perimeter defense, right? Almost no one invests on the internal side. So like things like, oh hey, someone's playing with files, or someone's plugging in USB devices, stealing our crap. You can have these security policies on paper, but the actual control mechanisms themselves are, very difficult to implement, and they're not necessarily
And brittle.
very brittle too. And it's not necessarily like the monetary hurdle; it's the actual resource and knowledge hurdle, right? Like perimeter is easy. Like here's a firewall. Put some
You say that.
that's cool, but that really doesn't do much.
No.
Right? Like, that's not what's
All it takes is one email,
exactly
right?
right. And actually, it's pretty much proven that the threat is inside every
Yeah.
time.
Yeah.
Right. So
The
it's
call is always from inside the house.
Exactly. There's no defense inside.
Yeah. Oh, I agree. Like,
That's my thought.
I mean, I didn't do pen testing for that long, but when I did internal network pen tests, it was always a cakewalk. It was just you would basically just choose which way do I want to get to domain admin, because you usually had a handful of options, right? So, Hillary.
So going back on to Nick's point that most people wouldn't hear. You said, or I guess Nick's got to be busy. He said that people don't really care what their router is, but that, at the same time, I bet 95% of people don't know what brand, even if they bought it themselves from a Best Buy, Staples, whatever. They don't know what brand of router they have, but in terms of antivirus.
Oh, they always every grandmother would be like, I have Norton.
I have the Norton.
I have the Norton. Yes, it's always the Norton. Yes.
It's like I've got the Norton, I've got the McAfee installed on my computer. They'll definitely know that they have.
Well, because it annoys them every year at least.
They'll have the Kaspersky, and they'll see that the Russians own the Kaspersky, and they'll think, I don't want to go with that.
What's funny is when I worked at FutureShop, I actually used to use that as a selling point. I'm like, Russians know their computer security. And I used to actually use that as a selling point, and before Cold War 2.0 started off. But now I guess all my poor customers are they're all hacked. Well, yeah, but you can't really blame their antivirus. They did buy a computer from me at FutureShop, so that was kind of their first mistake. Hmm? Oh, of course I sold them the package. That's how I made my money. That's how I made my money, guys. Yeah, so anyone else kind of have anything they want to, sort of add to this, or any questions if you're not super familiar with the story? Anybody at all? No? Nick?
I'm out of words.
Nick's, okay, apparently Nick is out of words. But yeah, so this this story just broke. What was it? Yesterday or the day before?
I think it was.
So-
I think it was the 5th.
So this is going to be developing. Lots of stuff is gonna go on with this. But yeah, if no one else, we got one more.
So I'm assuming this isn't just headline stuff, like assuming something actually comes of this and it is found that like the Russians were stealing information from the United States government. Do you think that's gonna like lead to something? Like,
Well, so
what do you think
I guess the reaction is, okay, let's assume worst case.
Right.
The correct question that you're basically bringing up here is, so what? It's like, it happened. It happened. A contractor clearly fucked up.
Right.
Like, there's no question there. He did something wrong, right? And a bad thing happened. But, like, so you have several problems. You have all the other political issues surrounding Russia that are at play here. This is just one to add to the pile. And the question is, does the current administration even give a shit?
Well,
Because that so far has not been very clear,
I
right?
was thinking if this is more like, do you think that this like is this going to be the thing that
The straw that breaks the camel's back.
pusher?
Yeah.
Yeah, that's what I'm wondering.
And
Is
I-
there going to be more sanctions?
I doubt it because like this is the NSA trying to find a scapegoat.
You know what? Yeah. Well, and this is the thing. I feel like they're just going to be like, oh, well, this was just another case to prove that Edward Snowden is a traitor. They'll probably just spin it like that somehow and be like, yeah.
It's like and who knows? Like it's just like okay.
At worst, maybe a little more sanctions.
When haven't they? Or Korea or China.
Yeah.
Like, I guarantee you, it's complete like hacking ping pong between countries. There's plenty of information they have.
Yeah.
Yeah.
This isn't like the first breach. This is the first public breach, and it's the only one that they're like, well, you kind of screwed up, and it was a really big deal because of WannaCry, right? And it's like we need someone to.
But I mean, the whole reason why you have all these policies and procedures in place, like don't load, top secret stuff onto your personal computer, is because everyone knows that if you're an NSA contractor or you work for the NSA, you are automatically a target for foreign intelligence. Period. Like, so, it almost becomes one of those things where you just have to be like, well, good game, Russia. Congratulations, you won this round. It will get you next time.
So you think it'll just it'll kind of fizzle out, I guess, in maybe public opinion of Russia?
I think there will be some hearings, and nothing will actually happen out of them.
Okay.
I think there will be a lot of grandstanding, a lot of big shows, and say, we're very angry with Russia, and then someone will propose sanctions, and then they'll say, no, they're our friends, we don't want to do that. And then, yeah.
I think one of the spots we might see some actual positive takeaways from it, though, is again maybe finally some increased scrutiny on things like contractors, third party, maybe hopefully some awareness that you should know a little bit more about what the software inside your network is doing. Again, you pay for a license for some enterprise product. Do you really know how it's functioning? What are all the implications of running that? Right.
That is a very optimistic view of how this could play out, I think.
I try to be a positive guy, John. I try.
And you know me, I'm not.
I feel like every time something like this happens, or just a big press of some sort of breach or anything like that, it's just what are the true ramifications of that breach?
Effectively nothing for the most part. Look at Target. So Target was owned through a third-party vendor. There was, I believe, an HVAC a contractor of theirs, and really, did that change anything in the industry in terms of how we handle third parties?
Yeah,
No.
we added third-party assessments to PCI. And
Oh,
so we get to make more money now.
Because PCI is so stringent.
Yeah. No, I mean, it changed the way we do things.
Somewhat.
It also
really change
doesn't, I guess, especially with Equifax, I was reading an article today, about people who are trying to basically pull out of Equifax, get all of their information removed from Equifax.
Can't happen.
And it turns out
You
they're
can't
one of
do
the
it.
top 3 credit bureaus, so even if you do that,
The one of the only 3.
yeah, good luck getting a mortgage.
No, but
Yeah.
you can now, if you want, because of all that, actually, they issued a statement saying if you want, you can have your credit report frozen and locked. but you got to pay them to do it.
Costs money.
So
to
they,
do it.
it's like turning like what do you call it, like a bad thing into an opportunity.
Yeah.
Like, that's amazing.
But yeah,
Anyways.
so by the way, I think I forgot to mention we were talking about the Equifax update. The number of affected Canadians was severely reduced to about 1,000 from 100,000. So yeah, it's again, it was very likely a very tiny subset of Canadians who had done some sort of credit-related thing specifically in the United States, which
That would
I
explain why they didn't offer us that free
Yeah.
lifetime credit and
yeah.
credit monitoring.
This goes to show you how much crap GDPR is going to be in the coming future, right? Like, one of their requirements is like, oh, you must have full breach understanding within like 2 days, practically. You know, and it's just like, as you can
That's
see,
never
like,
gonna happen.
that is literally impossible.
Instant response guys are gonna have a heyday charging money for that.
Yeah, it's
Like, oh, you want our express service so that we figure out what's going on in 2 days?
Yeah.
Okay, that's going to be triple the price of our usual rate.
Exactly. It's just, but, you know, it just goes to show you, like, there's a multitude of complexities.
Oh, it's ridiculous.
Right?
It's ridiculous.
And on every single level.
Well, look
Yeah.
at the long tail that this story has, right? So you get the leak of the tools that leads to equation group, that leads to shadow brokers selling it, that leads to WannaCry, that leads to. I remember when the malware tech blog guy like registered that domain that killed it. So it led to like that guy getting kind of famous. Then it leads to that guy getting noticed by some government agency and him getting arrested when he went to Las Vegas, and now he's being held there for allegedly working on malware for some other worm that happened. Like
So
the
Eugene- so-
ramifications of
So,
this
so Eugene
thing are
Kaspersky
huge.
personally got Marcus Hutchins arrested. Is basically what we're saying.
Yeah, pretty
Okay.
much. So that he
Okay,
should punch
cool.
him.
Is
Yeah.
he out now or what?
No,
still
he's
in
under
the-
house arrest.
Yeah.
Okay.
Well, not sorry, house arrest fully, but
He
can't leave the US.
he can't leave.
Still in the United States.
Yeah. And he has to check in with like some I don't know parole officer or something like that.
Yeah.
It's not parole,
Yeah.
but
An innocent
He
person.
tweets about experiencing American food and stuff. It's pretty cool.
yeah,
So an innocent person, though, right? Someone who hasn't been proven guilty yet.
correct.
Yeah.
Correct. He's technically innocent at this point. Because we don't. The thing is, we haven't seen the court proceedings, so we don't know what evidence is going to be presented against him. Really, we've only heard little tidbits of what they may have, right? And a lot of it might be circumstantial. So, anyways, that'll wrap it up for the news. As usual, we'll take about a 5-minute break to get set up, and then we're gonna have Aaron come on up and give his talk. So, you guys want to stretch your legs? We'll have a little break.
Just got the
How did this get? Oh.
I don't know. It literally just. Oh, I think someone hit it.
Like a sophisticated setup.
It's very. Hey, you know what? Whatever works.
Super hacky.
Honestly, whatever works.
No. There's the microphone.
Yeah, I'll get it because I'm just watching. Yeah.
Okay. Hi. We're gonna get started again.
All right. Hey guys.
And gals.
Welcome back, guys and gals. Welcome back.
So, our guest speaker this week is Aaron Hnatiw from Security Compass. He's going to be presenting his talk beyond OWASP Top 10, which is going to be super great. I don't have a bio for Aaron, so basically I'm going to tell you that he's wearing a sort of purplish shirt. He enjoys Novembers and walks in the rain. Take it away. Aaron.
Everything that he said is true. So let's talk. This is beyond OWASP Top 10. So this is a presentation that I've given at a few different conferences, but you guys are in for a special treat because you get one that I've never shown to any other ones, and specifically you'll like it because of the end, what I do at the end. Before I get started though, that's a big screen. Before I get started, I have some pumpkin spice sweaters, is what I like to call them because they're an orange color, and I'm going to be giving them away throughout the talk. So I'll ask questions sporadically, and whoever can answer it will get the sweater. And before I get started, who here is currently a student here and actively studying instead of out working now? Cool. A lot of you guys. That was a trick question, but you know what? Yes, you get one. All right, so I'm gonna lay them out right here. Yeah, they're different sizes, so without disturbing people, just choose one. Thank you. So there's 5 of them, I believe, so there's 4 left. I know, pressure's on. Okay, so let me get started here so we don't run out of time, because I want to be able to answer questions at the end, any questions you guys have about this or whatever. So let's dive in. This is me. As Nick said, my name's Aaron. I gotta stop looking up here. I have a screen right here. My name's Aaron Hnatiw. I'm a senior security researcher at Security Compass right now. There's a few other people here from Security Compass as well. In the past, I've kind of done a lot of different things, including I was a professor at Georgian College as well, so this whole thing is pretty familiar to me. I've been a security consultant, sysadmin, web developer, software developer, all that fun stuff. So I've kind of run a bunch of different careers in IT. And it's always led to security, and that's where I am today. I make a note of my Twitter profile here because I usually post a lot of the stuff that I find throughout my research on there. So if you want to reach out anytime or you just want to kind of see what I'm working on, that's probably the best place to reach me or the best place to check that out. So feel free to reach out to me there. So let's start with talking about what this talk is actually about. So this talk is about OWASP. More specifically, it's about the OWASP Top 10. So for those of you that do not know, OWASP Top 10 is the top 10 list of most common vulnerabilities in web applications. Now, whether it actually is the most common ones is up for debate, but it's a list of fairly common web application vulnerabilities, and it's a class of them. But the problem with it, so it's great as a start. It's a great place to get an idea of what's out there in web apps and web app vulnerabilities. But the problem is it's not really comprehensive enough. It doesn't cover a lot of vulnerabilities. Specifically, the problem with that is that a lot of organizations actually use the OWASP Top 10 as their guiding standard. It's not really a standard, but their guiding standard or methodology for what to look for in their enterprise when they're talking about web app security. So here's a survey from a recent, I think it was a 2015 SANS report that basically they interviewed a bunch of these organizations about what they're using, what standards they're using in their org, and the number one that they referenced by far was the OWASP Top 10. So a lot of these organizations are relying on the OWASP Top 10 when, in reality, it might be leaving them blind to a lot of other issues. So before I get into those other issues, which is kind of the meat of the talk, I'm going to talk a little bit about the OWASP Top 10 for those of you that aren't as familiar with it. So the most recent full one is 2013. There's a release candidate that came out this year. It's still kind of under review. There was some drama around it, which I can maybe get into later, but I'm going to cover the 2013 one, and I'll talk about the 2017 one later. So 2013, again, there's 10 different categories. First one is injection. So injection is really referring to any time where an attacker can inject their own code or their own data into a query or into a string, and it gets interpreted by a system in the back end. So an example of this actually, this is a perfect opportunity. Can anyone give me an example of something that would fall under the injection category? Yes. SQL injection, you got it. You get a sweater. That row is killing it. All right, so SQL injection is an example. Direct command injection. There's a lot of things that you can do to get injection through a web app. I'll just remember. You can grab one after. The next one is broken authentication and session management. So this really just refers to any issue where authentication is broken or session management doesn't work. So for example, if you can easily guess the session the session key, the session token, if you can steal a session token really easily, or there's no authentication. So these are different issues that fall under A2. A3 is cross-site scripting. I mean, it's pretty generic. Just anytime an attacker can get JavaScript to run in a client in a user's browser, that's cross-site scripting. Insecure direct object reference. If you ever look at a web application and you go to a page and it's got a specific ID that you reference, if you can change that ID and access another page maybe that you're not supposed to access, that's an IDOR vulnerability. Fun fact is that actually exists a lot on the web. So if you're ever, I'll just say, doing a bug bounty where you're legally allowed to mess around with the website, and you see a particular ID, try changing that and iterating through that, and just change it by one, go back one, change it to number one, see what happens, and that actually is fairly common. Next one is security misconfiguration, which is just a general catch-all for you're using something and you're not configured securely. So for example, if you're using MongoDB, by default it has no password, no authentication on it. Or if you're using, Java Springs framework and you have like CSRF disabled or something, CSRF protected disabled. That's an example of security misconfiguration. Last five, sensitive data exposure. Basically, if you're not if you're not encrypting at rest or in transit, so if you're not using TLS or you're in some way data gets exposed, or if you're Equifax, that's an example that they are A6. But whenever you have some way that your data is getting exposed, either in transit or at rest. Missing function level access control, this basically means that if you, instead of just like authenticating or authorizing users at the entire web app level, so you need to log in to get into the whole thing, there's particular functions that may need more granular authorization to it. So for example, admin functions may need a whole different level of authorization than a typical user function. So that's an example of this, where if you could go in as a regular user and anonymous user and execute some kind of admin function, it would fall under this category. Cross-site request forgery. This basically means that if a attacker can get you to submit a form to a web page, by default, browsers will, this is the standard behavior, browsers will include the session key or the session token and all cookies with every form post. So any request to a web page will include the cookies associated with that web page. So if a user or an attacker can get you to submit a form that calls a particular function, it will do so, if you're already logged in, it will do so with your cookies or your authentication or your authorization tokens as well. So if they can get you to do that, then basically they can get you to call a particular function with your permissions. Using components with known vulnerabilities. This is another one that kind of is a bit of a catch-all. So if you're using something that's not, basically patch is what it means. Just make sure you keep things up to date. Whatever libraries you're using, OS it's just kind of a catch-all for that category of vulnerabilities. And finally, unvalidated redirects and forwards. Fun tip, if you ever see URL equals in anywhere in a request, whether that's in the request body, whether that's in the cookies, or not likely, but request body or URL itself, try messing around with what URL equals goes to. So if it's forwarding you to another web page and you can change that to anything, then an attacker could basically force you to go to their own malicious web page and run something on your computer. I'm going to get to a use of this in the first vulnerability that I'll talk about. Oh, which actually is coming up next. So server-side request forgery. This has a CWE, but what server-side request forgery, or SSRF as I'm going to call it, so I don't have to keep saying those same 4 words over and over again. SSRF is basically when an attacker can get a server to perform a particular request on their behalf. So they can force a server to send out traffic somewhere else for them. And I'll get into what that actually means later. What this allows is, for example, allows you to bypass firewalls. So if you can make a server perform a request to somewhere else, and that server is trusted but you're not, then you can do something that you normally couldn't do as an attacker. So if you have a server make a request out to, let me see, am I covering that? Yeah, you can make a server reach out to the internal network, but you can't reach the internal network, then that's seriously, it's not a good thing. So because a server typically has an interface to the outside network and the inside network, if as an attacker you can force it to make a request to some kind of internal IP address range, or even the local one, which I might cover later, or even like the local address, then you can basically bypass those restrictions that edge firewalls or normal IPv4 standard won't allow you to make a request to. Through SSRF, it basically turns a application level attack into a network attack because you can do things like perform this. You can do things like do enumeration and reconnaissance on an internal network, on other networks. You use it as a proxy that does essentially your enumeration for you. It can make these requests for you. A benefit of that is it hides your IP. So if you're making a server make a request out to another server at point B, that server at point B will only see the source address of the server that is vulnerable, not the attacker's IP. So it's really, really helpful in attacks where an attacker needs to hide their information to use if they can find an SSRF vulnerability. Really helpful in that. And this is how it's often introduced. So same origin policy is what SOP stands for. Same origin policy is essentially a feature of browsers, a security feature of browsers that prevents one domain from making a request to another domain and receiving data back. So if a particular web application needs to do that function, let's say in JavaScript, there's ways that attackers have, that developers have enabled attackers by trying to find a way around that. And that often turns into a server-side request forgery. So for example, if instead of through JavaScript, they need to make a request out and they just basically do it on the server side and then return the page back through the browser, that's bypassing same origin policy, but it essentially introduces an SSRF vulnerability. Because if an attacker can influence where that request is going, they're off to the races. I'll talk a little bit more about same origin policy in a bit. And in a particular case that I'm going to talk about in an exploit, if you can make a request out to a page that returns back malicious JavaScript, then you then have a cross-site scripting vulnerability that's leveraged from server-side request forgery. So let's talk about specific exploits that are affected or that are created from server-side request forgery. I'll give you some exact examples that have actually happened. So first off, this one's querying AWS metadata through server-side request forgery. So this actually happened. First thing, the attacker, this was, I believe they reported this through a bug bounty. What was the URL I gave? No, it's, okay, I think it's through a bug bounty, but this is the way that it worked. So you see there, this, remember how I mentioned that before, URL equals? That's usually, attackers love that. So if you find that, start playing around with it. I'll show you how in a minute. But the attacker found this endpoint, and the function is actually mediapreview.php. So that's a page that has some functions in it. And if you pass it the URL parameter, what it basically returns back is the preview of the image that you called. So the downside is it should only load images back to the page, which, I mean, you can't really do much with images. I've seen some really crazy polyglots with images before, but that's kind of getting to a whole level of crazy attacks, which likely wasn't valid here. So it only loads images, but the thing is, it doesn't actually check whether, really well, whether it's an image. Instead, it just checks whether it has the extension of an image. So this guy, his domain was zayat.org. He just passed in his web page and then just passed in a parameter that he didn't even do anything with, just so that it passed the check. So he passed in just question mark the parameter .png. Doesn't have to do anything other than that. And basically when he did that, it returned back the whole front page of zayat.org in the web page without an iframe. So just returned it back, which is not good. So if he did that, he just leveraged that, and then he just passed it a whole page full of an attack called cross-xss.html, and then boom, you have XSS. But that's not all. That's not all they did. So they didn't just stop there at looking for returning cross-site scripting through a server-side request forgery. So the request forgery came in when the server itself at here, play.esca.net, it then made a request out to this URL for him. So he didn't have to make the request, he made the server make the request. And then he returned back, he just loaded up a cross-site scripting page with just basic JavaScript on there, probably popped up an alert box or something. He loaded that on his website and then got the server to make a request for it so that any user that goes to this page, well then it will return back cross-site scripting in the user's browser. This is something that I'll kind of make a minor point about is there's a vulnerability type that I sometimes talk about with this talk called overly permissive regex. Basically what that means is your regular expressions can introduce a lot of vulnerabilities. If they're complex, if you don't really know what they do, or if you're not checking the right amount of things. So in this case, they were only doing a regular expression for the PNG type. They relied entirely on a regular expression and not like metadata checking or any other kind of checking for it, whether it was an image or not. So that's a comment on overly permissive regexes. So they didn't stop with doing cross-site scripting from this SSRF vulnerability. Instead, they continued and really leveraged the fact that this server was running on AWS. So many of you who may have corporate experience now probably are familiar with AWS because a lot of companies use it for their cloud infrastructure because it's powerful, it's massive. But one thing that I guess the attacker used, one piece of knowledge that they used, was that if you query a particular IP that should only be accessible internally to a server on AWS, it returns back all sorts of metadata. So what they did was, if you can query this page, it will pull back metadata. So what they did was, they passed in that as the URL, and it returned back all sorts of data about that AWS account in the page, and boom, they had like full AWS account takeover. It was awesome. So they didn't just stop at cross-site scripting, they leveraged it because it was on AWS to return back everything about that AWS page. So if you want to know more about how that works, because it may come up in the future, especially as you work more with AWS, check out this documentation here. I can provide the slides for this after if you guys want, so you don't have to like scramble to write this down. But this has some more information about it, and there's a lot of data that you can get. And I actually have some examples of things that you can get. So you can get things like the AMI ID, local host name, public keys / OpenSSH key, security credentials for roles, security groups, all sorts of stuff. So that's what they did using SSRF. I'm going to show you another exploit. This one I called Google Digs Google because it's clever. What it did is who's familiar with the term dig, or with the tool, the dig tool? So it's a command line function that is common on most Linux systems at least, where you can make a request out to a name server for a particular domain and it'll return back information about that domain. Basically, you can see here, Google made this function basically available through their Google Toolbox in a web application. So if you make a request to, using this name server, which is the Google name server for this domain, it returns back, domain information about it. So it says where the IP is, it says what the domain is in an A record, things like that. So it basically does dig in your browser. But what Google didn't really, and this is Google, okay, so Google knows their stuff pretty well. What Google didn't anticipate and what an attacker found was that you can actually modify the request and change the name server value. They changed it to localhost. So 127.0.0.1. Turns out that server that was running this web application was also a name server. Cool, I guess, save on resources. Why not? So what happened was they changed the name server to this, and then all they had to do was just iterate through, where is it? Here we go. Iterate through these domain values. And what you can do is just keep passing in domain values. And what this attacker did is they just iterated through the entire, they just kept throwing, word lists at this, and they enumerated all of Google's internal domain structure. Everything, all the domains in there. So they just modified the name server that was used, changed this, and just iterated through it, and they found out everything that Google was running internally. Fun fact, Google was running a Minecraft server at minecraft.corp.google.com. So this guy actually leveraged this, and I think they got it through a bug bounty, through Google's bug bounty. So how do you test for SSRF? There's a lot of things that you can do, and I'm sure you've picked up a few of them throughout this presentation. One is if you ever see a URL in the parameter, or URL parameter anywhere in a query, try changing it. So some ideas of what you can change it to include, a remote URL or IP. See if it makes a ping out to that. See if it comes back in your browser. A loopback address. So if you can actually call the local address, then you can, enumerate through different ports on that local host or other addresses that might be hidden on that local host, and you can see everything that's running there. Local IP as well. So if you can pivot, or if you can just get access to that internal IP address range, which you can if one of these, this vulnerability pops up, then you're off to the races. Now this is actually really interesting. You don't have to just query HTTP or HTTPS. There's lots of other protocols that you can use through this URL wrapper. So file, SSH, FTP. File is particularly interesting because you have the right permissions on the server. You make a query out to, I don't know, /etc/password or shadow, then you can essentially, that's step one to cracking all the passwords on the system. So you can access the local file system as well. So there's a few other protocols you can use. I'll talk about some more in a second. Try a different port. See what else is running on that server or on other servers. Essentially, this turns your web app attack into whatever that vulnerable server is, becomes a port scanning tool for you, which is cool. And Burp Suite Intruder actually helps you automate this. So I kind of showed changing the request, but Intruder, if you use Burp Suite, I'm not sure if it's available on the free or if it's limited, but whatever. Burp Suite Intruder actually makes it a lot easier to automate this. You can write your own scripts to do the same thing too. And if you're using Intruder, you can sort it by response size to see, like the higher response sizes usually means that something bigger and more substantial came back to your request. And you can actually, if you have XXE, so this is external, XML external entity attack. Basically, if you can upload a XML file, there's a way that you can do it through this attack where you can actually specify another location. So you can actually get it to load, make a request out to another IP, to another domain, and return that back in the page. So it's essentially another form of SSRF as well. And so here's an example of doing that, that attack. What else did I write on this? Oh yeah, so here's, I'm not gonna go into this in too much detail, but just know that this is kind of another way to introduce it, is if you can upload an XML file, you can then get it to call out to another domain. And collaborative servers allow you to, like if you wanna make a request out to another public IP and you wanna see whether it hit, you can either spin up something on your own on like DreamHost or on DigitalOcean or something like that, and just log to see, look through your DNS queries or look through your Apache logs to see what came in. Okay, so let's talk about defense and mitigation. Because if you're going to be doing this, especially if you go out and work as like a pen tester or you work corporate security, you're going to need to know how to defend against these things, not just attack them. So let's talk about how to actually defend against it. First off, I talked about same origin policy earlier. It exists for a reason. It's there to block requests out to other domains and getting data back, because typically that's not usually a safe thing to do. So don't use something like JSONP, which is made as a workaround, or other server-side workarounds. Because other server-side workarounds basically means that you're making a request out to another resource, returning it back, which is SSRF. So there's better ways to do this, and that's through CORS. So CORS is cross-origin request sharing. Or cross-origin resource sharing, thank you. Yeah, cross-origin resource sharing. And what that basically means is you can set up a rule on a server, on a remote server, that says any request from domain a.com to me, I can accept it and return back these certain content types. So whether it's HTML, CSS, JavaScript, whatever. So if you use a CORS rule, that basically means that you're enabling this functionality to a specific trusted set of resources. You can allow all if you really want to. I'd highly recommend not to. But you can whitelist particular domains to be able to make those requests out to that other secondary domain. So instead of doing server-side workarounds, as much as possible, try using CORS. And whitelist is always better than blacklist. Just remember that in general, it applies to the network side as well as the application security side across a lot of vulnerabilities. But when you're doing this application logic to be able to make requests out to particular domains, make sure you whitelist the domains that you want to allow. Only the ones that you want to allow out. It's just not only the domains, but also the protocols as well, because as I'll show in a second, those protocols can also change. And then again, a good general practice is just sanitizing input. So just being sure that whatever input you're getting to your requests, to your server, is what you expected. And key here is to prevent it from going from bad to worse, do some kind of access control, whether that's like local internal firewall or just turning off your internal network access. Whatever you need to do to prevent that external source from getting into the internal source if you have an SSRF vulnerability. And again, why would we want to whitelist protocols? Well, I mentioned before you can use file, FTP, SSH, but that's not all. If you use something like PHP, for example, by default, it will allow the following protocol URLs. Do we really need a zlib or data or SSH2 or RAR, or file? Do you really need that on your server? Probably not. So this is where whitelisting really comes in handy, is not just the domains and the IPs, but also the actual protocol URLs that you're using as well. So here's some more information on that if you're using PHP. Okay, second one. I should get a drink of water here so I don't dry out. Second one is going to be race conditions, and this is one that I'm really excited about. Before I get into race conditions though, question time. Who can explain to me what SSRF is? Yes?
So if it's a server-side request forgery, basically what you're doing is you're tricking the server into making a request on your behalf.
You got it. Sweater for you. Good job. So that's SSRF. Try to remember that, but again, this is recorded, whatever, if you want to go back to it. Race conditions. This is really fun. I did a whole talk last year on race conditions. It went really deep and also talked kind of in more depth about some of the technical aspects of the defensive measures. But I'm going to give a bit of a high-level overview here, and then we're going to get into something fun. So race conditions is defined as when the timing of actions impact other actions. Events may happen out of sequence, which can result in anomalous behavior. So essentially, when you are making assumptions about the order of operations in a asynchronous or concurrent environment, so if you have things that are happening at the same time, and you're assuming they're going to happen in a specific order, things can go badly. And I'll talk about how that works in a second. So, as a visual example here, if you're expecting, I don't want to talk with my back to this thing, if you're expecting, because process X here, so process X and Y are happening at the same time. If you're expecting process X to finish second because it's got 4 different actions, and process Y is 2, I mean, that's a fair assumption. You know, it literally has half the things it needs to do versus process X. If you're making the assumption that's going to happen, but maybe this happens, bad things happen, especially when you're dealing with shared data. So kind of a background to this is race conditions actually is a known computer science problem. It's not necessarily, hasn't always been known as a security vulnerability. It's been an issue since we've had concurrent languages or concurrent programming. And it's something that has been, the source of many bugs that are sometimes the most difficult bugs to find. And I'll explain in a sec how that can be leveraged for security vulnerabilities. But the way that this kind of works is when you're talking about multitasking in a typical application, oftentimes it doesn't mean that things happen at exactly the same time. If you don't have multiple cores and it's just using threading, what it's really doing is it's actually just switching back and forth really, really quickly. That's kind of how our brains actually work. There's not really such thing as multitasking as much as we want to believe it. You're just kind of switching back and forth between things really, really quickly. So in this case, what could happen is process Y could start, but then suddenly this thing is going to take a little bit longer, or for whatever reason, the processor switches to the other process, which happens all the time. This is how it does multi-threading. It will then run this, and because maybe it runs really fast, or for whatever logic is involved in that processing of this application, this may finish first. And when that happens, it can lead to anomalous behavior, which basically means things can happen that you don't expect to happen. And whenever things happen that you don't expect to happen, that can usually be leveraged in some way by attackers. So let's talk about specific exploits. A really fun one had to do with Starbucks gift cards. So Starbucks, some of you may have already seen this before. This attacker, I think this is Igor Homikov. Yeah, so he's at security.com. He posted about this a while ago, but what he did was he basically took 2 Starbucks gift cards. These gift cards had real money on them, a small amount for testing, but they had real money on them. And he basically exploited the way that the developers assumed these accounts would transfer money. So the assumption, so you can transfer money between gift cards, no problem. It's a standard function of a lot of different monetary systems. But between these two gift cards, the logic went like this. Step one, you check the balance of card A, see if it is sufficient to transfer the money. If it is sufficient, step two, transfer the money to account B. Step three, update account balances in account A and account B. Okay? That's oversimplifying it, but the idea is that it happens in those steps. That's the assumption that we have. But what Igor did was basically challenging that assumption because he knew that you can actually force it to happen concurrently. So what he did in particular was he made a request to that endpoint that transferred the money. But he didn't just make one request. He made many requests, like hundreds of requests all at the same time to that web application, and it processed them all at once because it's got, Starbucks they have thousands of customers. They probably need to, make them happen right away. So what they did is they could process all this at the same time, but because of that assumption that I was talking about, when it did that first check for whether account balance was valid, so let's say there's $5 in the account, you want to transfer $5. For the first one that comes in, it says, okay, there's $5 in the account, check, move on to transferring money. But if before it gets to that third step of updating the account balance, another request comes in and it checks whether it says, okay, is there enough money in account A? Yes, there is, because it hasn't been updated. There's no reason why there wouldn't be. Makes the transfer. So it happened, probably hundreds of times at the same time, transferring that money before it was able to update the account balance in account A, basically resulted in free money. So account A transferred over way more money than it actually had in the account because of that logic that Igor exploited. So that's one example of a race condition gone wrong. Second one is actually also kind of fun and a little ironic, is a bug bounty hunter found a vulnerability, reported it to Cobalt.io, and you can actually in Cobalt.io at the time, I'm not sure if it's still valid, but you could get paid in Bitcoins. So what they did after they got, it was a valid bug bounty submission, it was fine, they got their payout, but what they did was, because the assumption by Cobalt.io was, check whether the bounty has been paid out, make the transfer to the account. If it hasn't, update it to say the bounty has been paid out. What this researcher did is he just made a whole bunch of requests to that bug bounty payout at the same time, and it made a bunch of requests out before being able to update to say that it had been actually paid out. And they got a bunch more Bitcoins in reward. And they got another bug bounty reward for that one.
Did they do it again?
I think Cobalt.io caught on after the first one. Yeah, you'd hope they'd learn, right? So that was how that one worked. So let's talk a little bit about testing for race conditions. Interesting thing about race conditions is this is still very new and not a lot of people are looking at them. So I did this a talk on race conditions last year, like November at Hackfest, and at the time there had been I don't think there was really any other talks that were recorded or I could find anywhere on race conditions. And it wasn't even that popular in bug bounties. So if you're looking to do bug bounties or you want kind of an edge on pen testing, take a look for race conditions as well because it's often not being looked for. So let's talk about white box testing. This is kind of the best way if you can get access to it. Basically, this means that you have access to the source code. So you have access to the source code. Before I get into this, I'm going to actually speak about one other thing. Before I mention that it can be worse if there's shared resources that are being accessed concurrently. The reason for that is, so for example, if you are accessing, let's take the Starbucks gift card, for example. The shared resource is the database entry that has a list of the actual account balance for account A and account B. So that is a shared resource across a number of different processes that can make a request access to that resource at the same time. Because it wasn't really regulated or wasn't really done correctly to check for this kind of thing, you had many different people or many different resources accessing that one resource at the same time, and it resulted in that race condition. So oftentimes these come to be because of concurrent access to one single resource. So when you're looking at white box testing, you have access to source code, this is kind of the thing you're going to be looking for. So let's take a look at step one. Step one is just identify that shared data. So take a look for whether you have files being accessed at the same time, whether you have, even just in programmatically, if you have data structures being accessed at the same time. So try to find those resources, or database objects, where you're accessing that at the same time. And if you think that this doesn't apply to certain non-concurrent languages where they don't have it built in, I challenge you to think again, because PHP was not built at a time where you could really do many concurrent connections. PHP doesn't have a notion of concurrency built into the language. But because it runs on top of like Apache and Nginx, which can take concurrent requests, then it can also be vulnerable as well and not really prepared for it the right way. So the defensive measures I'm going to talk about later is a lot more difficult to implement in PHP because of that. But anyways, I digress. So first off, identify shared data, and then find out where it's accessed across the different systems. Then you want to find out where it's not synchronized. Synchronization is key here. So find out where that data access is not synchronized, and then just send a ton of requests at that endpoint, see what happens. Or even just look at it if it's not locked or it doesn't have any kind of defensive measure that I'm going to talk about in a minute. If it's not synchronized properly, then you know it's likely a vulnerability. Black box testing. So this means that you don't have access to the source code, which is most of the time, especially if you're in pen testing, you're not necessarily on the internal security team. So I wrote this tool here to do just this. It's free, open source. Anyone can use it. Anyone can look at it. It's written in Go. I don't know how many of you are familiar with Go, but that's what it uses. And it actually is built specifically to test for these kind of things. So it's available just for this particular purpose. And I know a number of pen testers that have used it and actually benefited from it and found vulnerabilities because of it. And what's more, I actually built an entire vulnerable web application to use it for testing. And Burp Suite Intruder is another tool that you can use. Recently they came out with similar functionality, but I will say that in testing, mine's actually faster and it does a really good response comparison, but I may be a little bit biased. But I'm going to actually show you exactly how that works. So this is the fun part that you guys only get that no one else has really gotten yet with this talk. So let's do a demo. So I didn't pray to the demo gods before, so let's hope that it actually works out here. All right, so let me set this up here. All right, so we're gonna rob a bank. So this is Speed Bank International. This is racetheweb.io that I was talking about. This is an application used to test for this. So this is a fictitious bank. I really hope this bank doesn't exist. I really don't, for a number of reasons. But basically what happens is you go to this bank website, and what you can do is you can, let me see if I can get my mouse over here. Where's that screen? Oh, there we go. Okay, so you initialize the application, and you get $10,000, yay! So this basically says like you've basically logged into your account, and you have $10,000 in your account. Where's my mouse going here? Okay, so what I'm gonna do next is pass this over. And I am aware that this is small, I'm gonna blow it up in a second. Is that good? Can everyone see that well enough? Okay, cool. So first thing I'm going to do is I'm going to show you, let's see, config.tom. So this is just the backup file. The format is TOML, T-O-M-L. I think it's like Tom's obvious markup language. The reason I use that instead of like YAML or JSON is because it's just a little bit easier to parse programmatically. I do have a method for JSON, which I'll show you after. So this is what the configuration file looks like for Race the Web. It's got all different options, so you can send decide how many different requests you want to actually send. In this case, I'm going to send 100. And you can decide whether you want to see verbose output. You can use a proxy. So if you want to see everything that's happening, say through Burp Suite, you can do that too. Or if you have you're on a corporate network and you need to use a proxy, this will work as well. And then you define the request that you want to do. So what we're going to do here is we're going to take a look at the banking application, and we're going to make a function that, let's show you what function we're going to emulate. Let's withdraw, I don't know, $1,000, okay? So this is a function on the server where it basically says, I want to withdraw X amount of dollars. It checks whether you have that amount of money first, and it allows you to withdraw the money. So now we have 1,000 fictitious dollars in our hand. And our balance has been updated accordingly, right? Great, $9,000, awesome. What we're going to do is we're going to actually call that function 100 times, as I've put on here, and just to see what happens. What could happen? Actually, let's do it. No, let's not do 1,000. I'm not going to overload this network. And what I'll do here is this is the actual endpoint that I'm making the request to. You can see all this through Burp, like if you're intercepting requests or if you're just checking in the browser really quickly or in the network log, whatever. But I already know this, and just to speed things up, it's already pre-populated. And in the body, the way that this works is you send an amount that you want to withdraw. You know what, let's do 1,000. Why not? Big money, big money. So we're going to send a request each time to withdraw $1. We're going to do 1,000 times. And in here, because it's tied to my session, I'm going to pass in my session ID. Can you guys see this page well enough? Okay. I just got an easy way of grabbing it. This is my session ID. It's funny, when I demoed this at Hackfest, I did this in an earlier version of this. Someone actually took the time while I was doing the demo to write down my session ID, and they went and they actually did this on their own. And so they're like, "Hey, check your balance." And I looked in after, I'm like, "You got me." So I'm pasting in my session ID just so that it works, and following redirects. So these are different options that you have in the tool. But let's get to the fun part of this. So I've got the config set up. Now what I'm going to do is run race the web and pass in the configuration file. Now remember, we have $9,000 in here. We're doing this, we're withdrawing $1 1,000 times. So we should have $8,000 afterwards, right? Oh shoot, I don't want to do that. I'm going to output this so it's easier to read. Output.txt. So we're not going to see anything because it's outputting to that file, but it should show up in a second. So it's going to make 1,000 requests. Depending on how fast this network is and how fast my computer feels today, it should show up momentarily. Yes. This is where the Jeopardy music comes in, right? Maybe I did with that 1,000, right? Did I go too big here? Oh, come on. This is where verbose output would really come in handy. If only I had used T. So let this be a lesson to everyone. Use the program called T-E-E. It outputs to the screen and to the file if you're doing an output to a file. Okay, finished. Let's peek inside and see how bad things were. So let's, yeah, right. Oh no! No! Why? Oh, you know what? It's because I tried to do too many. Normally I do 100. It's fine. It'll be fine. This is why you record demos beforehand in case things like this happen. But that's okay. Let's carry on. Uh-oh. 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 Come on. Okay! Wait. I guess some of them worked. Okay, so some of them worked. So the caveat here is I don't think I ever did 1,000 requests in any of these demos. But depending on your machine and the size of your pipe, the size of your network, like the speed of your network, this program will actually allow you to choose whatever number you want. So I could send out 1,000,000 requests if I want to. My computer can't send out 1,000,000 requests at the same time. The network can't handle likely 1,000,000 requests at the same time. So just keep that in mind that you may get errors like that, but it's often because you're trying to send too much at once, and that's what happened here. Okay, so what we have here is this is basically looking at the responses that we got back. So what this tool does is it does a unique response comparison. So it takes a look at the data we get back and checks a bunch of different things. You can look in the source code to see exactly what it checks. But it actually looks to see how many responses back were unique. Because what should happen is when I make a request out to a lot of these resources, you should get basically the same response back. Or you should get completely unique responses back only. If it's any variation of that, then it's likely a race condition. So here we go. This is the first response back we got. Notice how it's all organized fairly neatly with headers as well as the body. Let's scroll down here to the part we're curious about. So there's the welcome. Cookie's invalid. Uh-oh. Maybe that's what happened. What I'm going to do here is instead, let's use private browsing mode because this is the real purpose of private browsing mode. Don't remember your session token. Race the web. Okay. Let's try this again. This time we'll do it with 100, and I probably copied the session ID wrong, maybe. Oh, maybe I didn't add quotes. I don't know. Bim. This is the fun of doing a live demo. Okay. Huh. Should be fine. Let's first, before I continue, let's change this to 100, and let's not be overly aggressive with this. And change this session, and I know there's a faster way to do this, but I don't care. All right. And go here, initialize. Cool, we have $10,000. Let's reduce this back down just so that we have a reference. Okay, let's check our session. If it shows it. Whoa. There we go. I can't see this very well. Do I have the whole thing there? Yes. Okay. No one's messing with me here, right? No one else is copying this thing down. There we go. Okay, that looks about right. Random enough, I guess. Okay, there's 100 requests this time. 100. Okay, so to recap, we have 9,000 in there. We're taking out $1 100 times, right? So we should end up with 9,800. Okay, erase the web. I'm not going to use T again. I'm just going to let it run. Let it ride.
That's not important here, David.
Oh, sorry, 8,900. Did I say 9,800?
Yeah.
Oh, thank you. That's okay, guys. Stay in school. All right. Let's run it. Come on. 100 times. See how much faster this goes. There we go. Okay, so don't cheer yet. Let's look for those errors here. Let's look at this. Yes, no errors. Okay. Thank you. The demo's not even done yet. I'll take it though. Okay. Great. So it looks like we're initialized. Welcome to SpeedBank. There we go. You have successfully withdrawn $1. That's what we want to see. So that's one request. The response back says we did $1. We have $1 out. Awesome. Even better, our balance is now $8,999. Right? That's exactly what should happen with one request. Now, what the thing here is that this tool does, see this number down here? That should be 0. So that's saying that there's one other request that looked exactly like that one, which means it had 8,999. Let's continue. Okay, great. You withdraw $1, 8,998. Great, that's what we want to see. 0 similar requests. Cool. All right, so let's see the next one. 8,997. And we saw 8,997 55 times. So let's go back to the page. Now, remember, it should be not 9,800, 8,900. Now let's refresh this page. And I'm going to click the button so you can all see what I'm doing.
You got $4.
So, no. If we look at the output, we took out $100. But our balance only says we took out $4. So we just got $100 for the price of 4. We just robbed a bank. What do you think? There we go. All right. If we could spend SpeedBank dollars, I would 100% cover everyone's beer. Don't cheer for that. All right, so let's go back to the presentation here. If I can find my mouse. There we go. Cool. Okay. So that was the demo. Worked out spectacularly. We robbed a bank through a race condition. So that's how the tool works, and you are free to download it. I have compiled versions because it's written in Go. What's cool is you can actually compile it to all major CPU architectures. So you can run it on like a Raspberry Pi, you can run it on Linux, Windows, Mac, doesn't matter. It works across all those systems, and you can go and look at it, the code, and compile it yourself if you want. One thing I didn't mention, and I don't have time to demo, it actually also has what I recently put in as an API. So you can run this as like a service, essentially, and pass in just make a simple JSON request, like pass in the data with the JSON request. So all your configuration data, pass it in as JSON data to that service, and then tell it to start, and it will run it automatically and return it back in JSON. So if you want to have this as like a race condition testing as a service, I would caution you against doing that publicly. But for internal build services, for example, if you're doing like continuous integration in a development shop, that's really key to have this as automated as possible. One thing I will note is just proceed with caution with this, because it's very likely that because you're sending a whole bunch of traffic to one location at once, that could cause stability issues with the service. So there's this is the Airbnb bug bounty, or at least it was when I checked last. Basically says that you can't do things like this. You can't do automated testing of especially a large amount of traffic at once. So just if you're doing this for bug bounties in particular, just read the terms of service or read the rules rather. And if you're doing this internally or doing this for pen tests, just make sure that it's cool that you can test for denial of service vulnerabilities, or just let them know that you're only going to do a limited set. So how do we defend against this? And I'm kind of running out on time, but I'm going to still try to cover this stuff. Number one thing that you can do, so if you're finding this and you need to recommend how do we fix this to your client, to your internal team, this is what you want to do. Locks are the number one thing that you need to do. So any shared resource that you have, use a lock on it. A lock basically means that only certain actions can happen at the same time. So only one person at a time, or you're restricting the amount of people that can update or create or write to a particular resource at the same time. A database has pessimistic locking, which basically means if it's in doubt, it will only allow one, or it'll kick you out. But if you're using an ORM, like an object relational mapper, which is basically doing database management programmatically, because it knows more about the application underneath, it can do more optimistic locking. Most languages other than PHP have locking built in, because PHP didn't really know about concurrency. There's a way that you can use semaphores, but then you can't have you can't have clusters of PHP. If you want more about that, you can check out the talk I did on this before. I give you a little bit more detail about PHP. But basically, PHP is difficult to secure things. File locks. So if you actually see Microsoft Word, most sharing and syncing services, they have this little file here. What that basically means is the Microsoft Word will look for this version of the file. If it sees it, it basically means that it's in use. No one else can write to that file at the same time. There's other ways that different systems do it, but that's generally kind of the idea, is lock it at the file level and include the logic in the program. Other things you can do to mitigate, but not necessarily completely remove this, is CSRF tokens, because it basically reduces, it doesn't stop it, but it will reduce the ease at which attackers can automate things like this. So if they have to check for a new CSRF token every single request they do, it becomes a little bit more difficult to automate really quick tests for race conditions. If a database is slow, it will be the bottleneck. In the particular case of Race the Web, the service that you saw, I don't have any kind of sleep timer in there. It's all because I'm using the lowest level of AWS databases, and because it's much slower than the web application can handle, it doesn't return the data back fast enough that faster than an attacker can make requests. So it helps if your database is really fast, especially if you're not using any kind of locking for whatever reason you need. If you're doing a database query, if you use inserts over updates, it's generally a lot safer. It has a lot of defensive mechanisms in place for things like this. And here's a few other things that you can check out. There's my talk. I think I linked to it also. If you go to racetheweb.io, it links in the top right corner. There's a YouTube link. It goes to that. And I also wrote a blog post specifically about this as well. And I can send you guys this after. All right. So before I get into this, for a sweater, who can tell me how a race condition works? Yes.
Basically, exploiting processes that are supposed to be performed in sequence, but you activate all of them once, and then they end up finishing before the sequence is correct.
Yep, you got it. So you got a sweater. Cool. So race conditions, remember, especially if you're in development, it's also, a lot of developers know of it as a bug, but you should know about it as a security vulnerability as well. So let's talk about the OWASP top 10. So here's the OWASP. How many sweaters do we have left, by the way? One left? All right. We got the countdown. So let's talk about the OWASP top 10 2013 recap. These are all the first 5. I'm not going to go over them again. The last 5. The thing is, here's the ones we talk about today. Server-side request forgery and race conditions. Those don't fall. If you think back to what they mean, they have a server-side request forgery where you can force the server to make requests on your behalf, and race conditions where you're basically abusing assumptions about the sequence of actions in a concurrent system. None of those fall under any of those categories in the OWASP top 10. So if you're relying on the OWASP top 10, especially the 2013, or really any of them, then you will ignore and forget about things like this. There's many more that I talk about as well, and we can talk about it another time or whatever, but there's a lot of vulnerabilities that don't fall under the OWASP top 10. So let's take a look at the 2017 one. I mentioned this earlier. This is the release candidate one. It's not quite final yet, at least last time I checked, but here's some of the changes that they made. So they basically made it so that these two, so IDOR and missing function level access control, get merged in together to broken access control. Insufficient attack protection. This one's the controversial one. So for those of you that have heard about this, or those of you that haven't rather, this was a new one that was introduced, and the whole drama around it was because one company basically introduced data that made it seem like this was on the top 10, when it really, they were the only vendor that actually fixed this or found this in their service. The other side of the story is that no one else submitted data really for this. Not many people were submitting data for this, so I mean, you only have one to choose from. But it basically means that defenders need to actively log, monitor, and like make active defensive measures as a part of their system, which has nothing to do, like that's not an attack. So that's where the controversy comes in. So this may be changed. Number 10 is a new one, under protected APIs. The weird thing about this though, is it's basically saying like protect your APIs in general. The weird thing about it though is that all of the OWASP top 10 categories, I've always in the past applied it to APIs as well. It does, like they all perfectly apply to APIs. They work the same as web applications in a lot of ways. So I don't know why they necessarily added a whole other one. Maybe they're short on resources, but that's number 10 now. Thing is though, it still applies. The ones that I talked about today, SSRF and race conditions, don't fall under any of those new ones either. So regardless of if your organization is moving to the new 2017 standard or OWASP top 10 as your standard for web application security, you're not going to be covered against a large amount of vulnerabilities. So if I'm going to leave you with one final message, is that especially as security professionals, as you are and as you are becoming, your job is really to educate developers, educate the people that are working with IT and systems in a network, in an organization. So the OWASP top 10 is it's a very good start. Don't get me wrong. Especially if a developer wants to know something about web application security and they know nothing, great resource to point them to. But as security professionals especially, we need to be sure that we're not limiting ourselves to that because there's so much more out there. So to do that, it's tough to keep up with some of the latest security trends, and coming to events like this are fantastic for that, going to conferences, because you can keep up to date with some of the latest vulnerabilities, the latest issues that are out in security. So you're not necessarily caught flat-footed by just knowing the OWASP top 10. So I'm going to give you a few resources to help you keep learning a little bit more. Other than coming to these things which are useful, going to conferences, there's a few other places you can look that I found particularly helpful. One is HackerOne is a bug bounty program. They have this activity feed. Basically, it shows you all the latest publicly disclosed bug bounties submissions. So it's really cool because you can see some of the newer stuff that people are doing, and I find bug bounty hunters are actually a lot of them are on kind of the leading edge. You can see some of the new things that they're finding if you check out this feed. Check out Twitter. This is my profile. The reason I mentioned Twitter here is because that's the first place I hear of almost any new security issue, any vulnerability. That's where I get a lot of my security news, and often it comes out, some hours, if not days, before mainstream media gets a hold of it, if mainstream media in general gets a hold of any of it. So that's my handle right there. I retweet a lot of this stuff out, and a lot of the stuff I'm working on and researching, I post it as well. So if you want a place to get started, maybe you don't use Twitter, I'm sure most of you do, just check out the stuff that I'm tweeting, and then you can follow those other people too. And it's just building your network of resources that you pull from is really the best way to get the most out of Twitter. Reddit has ISSessions. I'm sure a lot of you are familiar with this too. I don't really use it all that often, but it's valuable in a lot of ways. They tend to post some of the latest security issues. Usually comes out after Twitter, but it's there if you want to use it. And then again, HackerOne actually has a daily newsletter, which is fairly short, but it actually only came out in the past couple of months. It comes out every single day where they show some of the latest vulnerabilities, some of the latest bug bounty reports, and just latest security news. And for developers, you're going to point them to these resources. So developers, if they ask, how do I develop code securely? How do I know what to keep up to date with? Here's some resources they can use. SD Elements basically gives you a list of things you need to look for if you provide a specific application. type. Full disclosure, that's made by these guys that I work for, but it solves that problem. This is this top 25 by SANS and CWE. It's from 2011, I think it is, so it's a little bit older, but it still covers a lot of software security vulnerabilities that you might find, in code. I wrote also a blog post about just general top 10 security principles you're going to want to keep in mind, not just related to application security. And this is heavy. If you're building an application security program, or you want to know kind of an idea of what to look for when you're building an AppSec program or involved in an AppSec program, this is kind of the standard to go to. Again, because it's an ISO standard, it's huge and there's a lot in there and it's really dense, but it's valuable. It's good information to know. So with that, I hope you all have learned something new about web application security and some new things you should be looking out for, and I hope that demo kind of hit some of those points home as well. So if you have any questions, please feel free to reach out anytime. I'm going to show you, this is my email here if that works better, there's Twitter, whatever. Feel free to reach out. I'm happy to help and answer any questions you have. And so I won't take any of your time. Thank you very much for coming. So, I actually do have one more sweater to give away. I forgot about that. Let me think. If someone can tell me a vulnerability that doesn't fall in the OWASP top 10 that I didn't cover tonight, I will give you a sweater. Stupidity, social engineering, I guess, but let's talk about web application vulnerabilities.
I don't think Nick's allowed.
Anyone? Yeah, you got one?
What file include?
What file include? Does that fall on? It might be under injection, but I'd give it to you, yeah. You want a sweater? I tell you what, you take a sweater, you give it away to someone next week for answering something. Okay? Cool. All right, thank you very much, guys.
Thanks, Aaron.
Yeah.